So once again, hello and welcome, and we'll talk today about TypeScript, programming language, and I made a little assumption before, and I was assuming that some of you are actually working with PHP. Can you raise your hands if you're working on daily basis with PHP? Okay, that's cool. That was a very good assumption. Okay, so my name is Damian Tylczyński, and I'm working with TypeScript for the last 2-3 years. I could risk that it's my primary language, I think, and I really like it. It's one of my favorite ones. And after this talk, I wish that you will be able to write first few lines of code, and you will know some basic features that you can use to improve your code bases that are already existing. So let me recap. TypeScript is a programming language, of course. It's an open source one, and it's a superset of JavaScript. So basically every JavaScript out there, you can pass it to the TypeScript compiler, and it's a valid syntax of TypeScript. And TypeScript is adding additional features on top of it. And it was developed and it is maintained by Microsoft. And you can say, whoa, Microsoft is cool and hip, it's not sending people to the moon as Tesla wants, but it has a bunch of very smart people. And one of them is this man, and his name is Anders, and he is a lead architect of C#, and he and his team is responsible for creating and maintaining TypeScript. So you can ensure that that this language has a lot of people, smart people, with very good knowledge about language design. And I'm not the only person that likes the language, so it's 4th beloved languages according to the Stack Overflow survey. So before making this lecture, before making this talk, I was wondering why I actually choose TypeScript, why I actually like it. What is the reason behind liking the programming language that you're using on a daily basis? And this made me time travel 17 years back. And this was 2001, Max Payne was released. It's a lovely game, a fantastic one. I was a huge fan, and I decided to make a website for it, a fan page. So I found an HTML book, and I started to put HTML tables together, because this is how we have been creating websites back then. The CSS wasn't the thing, Internet Explorer was like winning, and was like monopoly everywhere. And then I ended up with hundreds of HTML files, and it was really hard to maintain the whole website. So somebody came to me and said, man, there is something like PHP out there. And I bought a book about PHP 4, and immediately I started to create really crappy code. So I was using a lot of super globals, it wasn't secure really, it was really a disaster. But then a year later I installed PHP 5 alpha version, and I pointed out documentation of PHP, all of those new features related to magic methods and object-oriented programming and so on, and I was reading. And PHP was growing with me over the years. So whenever PHP was adding something to the toolset, I was really curious what it is. And I was checking how it can actually improve the code quality of my applications. So I think this is the key point taken, that I really like languages which are evolving, which are having a feature set that can be used now and later on, and it will be growing on features with me as a engineer. So even maybe you don't know this name, Rod Johnson is the creator of Spring Framework, and if you don't know, Spring Framework is something like a symphony for Java, like putting it simple. Of course it's too simple to say, but he said, quote, "In terms of impact, TypeScript is the most important thing right now possibly." And I couldn't agree more, because it's JavaScript on steroids. So it's a superset of JavaScript adding some additional features. And then you can already take your JavaScript code that you have for the front end, for single page applications, for the backends, and you can start to put some features on top of it. So if you want to start, TypeScript compiler is written in TypeScript and basically runs on top of Node. So if you want to use it, you have to install Node.js, and you can use package manager of your choice. It could be npm or yarn. You can install a global package called TypeScript, and it will expose a binary called TypeScript compiler, and then you can compile your file. So basically you could even put there a JavaScript file, and it will output practically the same syntax. And we'll take a look at what kind of features it's adding on top of JS. So let's take a look at this example. It's a pretty neat feature. function that is printing out to the console hello something. And this is JavaScript, so it compiles. I mean, it compiles. It's running in the browser, it's running on production, but if you would run it somewhere, you would notice that it will fail because this simple ES6 JavaScript is having a bug because we are trying to push to this function, which is accepting string, because we can see that the subject is having a method to uppercase, or at least we are expecting this method to exist, and we are passing 42. So then you don't really know when developing, but actually you put a bug into your source code. So whenever you will compile it with TypeScript and you will add this little thingy, which will force TypeScript to know that actually the subject is a string, immediately you can see this red line on the bottom of 42, and you will see that TypeScript compiler is actually a string. I mean, it's pretty simple, right? And it can fix so many problems. So about types. So if you want to require a type, I mean, if you want to declare that some variable or a constant is of a type, you have to put it on the right side of the variable name after a colon. And in the end, you don't even have to do it. And later on in some other slide, when I will be putting some examples, sometimes I'm not even doing it because TypeScript is inferring the type. So TypeScript is saying, okay, you're assigning a string word to your constant, so basically this constant is a string. So you don't even have to specify it. The same applies to the functions. As we've seen before, you can require that some arguments are of some particular type, and you can additionally say what is the return type of functions. So you can see that also the type inference works properly, and whenever you want to do some comparison, which is kind of silly, so if you want to compare a string to a number, TypeScript will tell you that it's not really a good idea. As it's built on top of JavaScript, it's supporting classes, that's fine, so you can also do some object-oriented programming with it, or at least it will look for other favorite programming language, because it's basically a syntax trigger over prototype, but that's a different story. You can also put some constructors, and what is a nice feature that you can basically say and set up some visibility modifiers on your properties of the class, and additionally you can require them to have a type. So whenever you will do something suboptimal, TypeScript will not allow you to compile the file, and it will point that there is a types mismatch. So for example, in PHP you cannot actually do it. You can put types almost, let's say, everywhere, but whenever you want to say that a property of this subject would be a string, you have to put a PHP dog block. So in here, types are first-class citizens, and you can put a type declaration almost anywhere. So the other thing that I really love, and I found that is extremely useful in my projects, is constructor assignment. So you can compact all of those lines related to declaration of a property, argument in a constructor, and assignment of this argument to the property into one single line, just by saying that my property has a visibility modifier, so if it has a visibility modifier, it is a property. So immediately you are saving 3 lines of code. How many times I've seen a bug when people were assigning wrong arguments to wrong properties, because you could. And here you can avoid so many problems. And it has a really neat feature additionally. You can actually see what are the dependencies of your classes, because they are basically in constructor, and the rest of the properties that are not declared in constructor will be seen explicitly as things that the class actually owns, that maybe it's not exposed, maybe it's mutable, and only the class has access to it. So if you're creating object-oriented code, this kind of a pattern is very, very useful. So you can also declare your variables, or you can require as an argument an interface or a class. So in this case, I'm saying I want to have an interface of iPerson. But here things are a little bit more complicated. So it's not actually that the subject argument needs to be of needs to implement at interface iPerson. It actually says that the structure of iPerson needs to be met. And it might sound very weird. I mean, we are talking about the classes, interfaces, implements. That's totally natural, right? It should work like in PHP, but actually it's not, because TypeScript is using structural typing. So what does it mean is that in case of nominal typing, whenever the name matches, then everything is fine. typing, the names are completely ignored and only the structures of the interfaces are being checked. So let's look at this iPerson and let's add a new iDoc interface. So on both sides we have interfaces which are very similar. They are basically the same. They have the same properties, but they have a different name. So in case of nominal typing, like in PHP, those interfaces are not equal. But in case of TypeScript, there's an equality actually. So whenever you will be trying out TypeScript, you have to remember about it, because it sometimes might actually end up with creating a small background issue. There is a pretty big discussion regarding programming languages, what is more cool or what is more useful to have, or nominal or structure. Both of them are having advantages and disadvantages. So, for example, imagine that you have a class which has a method log. So it looks like a logger, right? In PHP, if you want to use it as a logger, like a PSR log or something like that, you have to actually implement the interface. But in TypeScript, you don't have to actually specify explicitly that this class is implementing this interface. You can just pass it to the method which requires this interface. TypeScript will check if the structures of these interfaces are matching, if your logger is the same as the logger in the other package, and everything is fine. Everything fits perfectly well. So this is an example. We're having these two interfaces. We are having a function which is meant to implement Doom the game, and we are declaring two constants, John and Riksha. One is a person, one is a dog, and we are passing to this, please implement me Doom the game a dog, and no errors are happening. Because TypeScript doesn't really care how the interface is called. He doesn't really care that those interface names are totally different while the structures are completely the same. So it's very important to remember whenever you will be writing in TypeScript that actually it is using structural typing, not nominal one. So it might seem for some of you like duck typing. I don't know if you heard this term. Duck typing is about checking the types of variables in a way that resembles, if something looks like a duck and acts like a duck, it is a duck. But it's not exactly the same thing as structural typing, because duck typing is running on the runtime, and on the runtime you're checking, okay, do I have this method? Okay, then I will call it. And typing is a feature of the compiler, so it's telling you if everything is fine already during the compilation phase and not on the runtime. So as TypeScript is built on top of JavaScript, it's implementing all of the types that JavaScript has, including the most beloved undefined and null, and string numbers, booleans, and symbols. On top of that, it's adding some new cool things that will help you both write and migrate your already existing JavaScript code, and including some new types that will allow you to take your already existing code base to the next level. So let's start with one of the patterns which are not really recommended, but there is a type which is called any, and any represents any possible type of a value, and you shouldn't ever use it in your projects. But let's imagine that you have a project of TypeScript and you want to migrate to JavaScript and you want to migrate to TypeScript. There will be some places where you will want to make a shortcut and define it as any, and sometimes really you don't really know what is the value, because then you want to validate it and sanitize the input which is coming to your application. So any is sometimes very useful. So you can see in the example that whenever we will define a constant as any, we can just call this to uppercase method, and TypeScript will not care. I mean, this will explode on production, this will explode whenever you run the code, but TypeScript will say, okay, it's any, it could be anything, it could be even string, so he doesn't care. So the void type is also pretty useful, and you could probably use it mainly for return types of your functions, because there it shows its strength. You can define that your function doesn't return anything, and then whenever somebody will be trying to make some comparison to whatever you're returning from this function, types will not allow you to do it because it will look silly, and this is not correct. You're not returning anything. Why to compare anything to something? So that's why this underline is there. It's coming from the compiler. You have a possibility to define how your lists or collections looks like. So you can have an array of a string, and here it might resemble for you generics if you don't know generics, but it's not really generics. TypeScript is supporting generics, but this list collections as array is not really a generic type. I mean, not in this format. You can, of course, say that something is a string, or you can even have a collection of things that you don't really know what they are using the any type that we have been discussing before. Then we have an enum, which is very useful for encapsulating, for collecting, very similar in the context in the domain constants. So whenever you're maybe abstracting some state machines or statuses of orders, you can put them all together, and it's a pretty popular concept. You have two versions of enum. You have a primary version, which is mapping constants to numbers. You can see in the first console log, and in the second version you can actually specify what is the value of an enum. So on the left side you have a constant, on the right side you have the value, and you can see it on the line 14. As JavaScript and then TypeScript is having objects as is having functions as first-class objects, which you can detach from an object, attach to an object, which you can pass around, and there's a lot of callbacks in JavaScript. So being able to define an interface for a function is a blessing. So it is using the interface keyword, and it's defining the arguments and the return type of a function. You can see a very simple example of a username provider, which always returns Chuck Norris. So you can specify the arguments, you can specify the return type, and TypeScript will be taking care that you're assigning the function, like your callback, to a proper value which has the same type, and it will be ensuring that you are calling your functions in a proper way, which is very, very useful. And last but not least, Indexable allows you to define a type for your maps or dictionaries. So whenever you have something which maps to something, like every user ID maps to a username, and maybe every user ID maps to a user object. So you can easily define this kind of structures, and you will always know what actually you have in this map or a dictionary. Very important thing that I cannot live without since I started to use it. Before TypeScript 2.0, every type was nullable, and this has a pretty evil consequences, because you can write code which looks like this. So you're defining that your name is a string. I mean, it's a type inference, so TypeScript knows that the name is a string, and then you can assign a null to it while it's actually a string, and it shouldn't be null, it's a string, right? And then you can also assign undefined, and still TypeScript is not complaining at all. And then you can even call a function with this undefined, which was the last assignment, and TypeScript is cool, no problem at all. So the really cool thing about TypeScript 2.0 is that you can use a flag, because TypeScript tries to be backward compatible, so you can use a flag for a compiler which is strict null checks. And to avoid this kind of problems on production, whenever you will enable it, you will change the behavior slightly. So if you want to use this flag or any other flag for the compiler, you can use a command tsc init, which will create for you the tsc config file, which will be used for any later compilation of your project or your file. TypeScript will be just looking for this file, so you will not have compiler command 2 A4 pages long, so it's very, very lean. So whenever you call this command, you will get example tsc config with filled all the defaults and all the comments regarding all the compiler options and other options you can use. So in this example, we are just putting strict null checks, and then compiler will be a lot more strict, and the null safety is there. So TypeScript is saying to us that it's actually not a good thing to assign null to a name, and it's not a good thing to assign an undefined, and it's really silly to call a function which is not supporting nulls with a null, which is pretty great. Of course, you can always say that you have a variable which value is kind of optional, because maybe you want to support null in some cases. So you can use a type, you can have a mixed type, so you can mix anything you wish, and as a string is a type and undefined is a type as well, you can mix both them two and say that our name is a string or undefined, and you can assign an undefined to it. Still, the function will be underlined by TypeScript, which will not allow you to pass undefined to the function which only takes string, but for it we have also a fix. You can use, I think this is the Elvis operator in the end, but it's just about adding a question mark on the left side of the colon, which indicates and which tells TypeScript that this argument is optional. So you can pass undefined to it, or maybe you don't even have to pass this argument at all. But still, TypeScript is telling us, okay, you are allowing to pass undefined, but in the line 2, in the console log, you're still directly calling to uppercase. And there will be a case when there will be undefined, and this will blow up on production, right? So TypeScript is helping with you, giving you some help and giving you some hints, and it's really, really smart because it's not only seeing the code as it is, but it can understand the flow of your application. So it will force you to actually deal with this undefined. So it will force you to somehow make an if statement and, for example, make a guard pattern, and whenever undefined was passed, just to return. So TypeScript will understand that after this kind of if statement, the forename that we are having as an argument is not a string undefined anymore, because there is no undefined. It will be just a string. So there will be no error. There will be no TypeScript compilation error. And it is actually allowing you to create a very neat and safe code for your clients. So there is a lot of flags regarding the safety, about the strictness, and so on and so on. And they are being added in new versions of TypeScript. So if you want to be backwards compatible, you can use the version on the left side, and you can add them one by one whenever maybe you will be adapting your code to be more strict, or maybe you want to have deterministic builds and you want to also have the same errors or the same no errors in your builds. And if you want to live on the edge, or maybe you're experimenting, just do -- strict flag and put it to true, and whatever new flag will be appearing in the TypeScript compiler, you will be getting it for free. There's another neat thing, and probably you already know the concept from other languages like PHP. In PHP, the annotations make a really big change, and TypeScript is taking annotations and putting them to the JavaScript, as we really, really like them, and they are very useful. And they are coming in the form of decorators. So there is a compiler option which is pretty experimental, but basically it's experimental, but the whole ecosystem and the whole community of TypeScript is already using it. So it's not that much experimental. Maybe it will change in the future, who knows, but there are so many huge projects, including Angular from Google, which is using it. So I don't really believe they will change it in a non-backward compatible way. I'm not really sure. So I think you can use it already. And this is the example from Angular. So by using annotation, you can simplify your code a lot, and Angular will be able to discover all the components of your application, and the code is much more cleaner afterwards. And if you work with PHP, you probably know that annotations are very often used by ORMs, and actually bring this kind of ORMs to JavaScript. So you can use annotations. If you write applications in Node.js, you can use a type ORM, and it's using annotations to specify entities out of the classes from JavaScript. So it's pretty cool, pretty enterprise. If you will be playing around with TypeScript, let's say you're leaving the lecture and you want to write a few lines of code, I really recommend to take a look at the Google TypeScript style. I wasn't using it by myself, but I heard very good opinions about it. The main key point out of it is that it's providing you the formatters which are predefined, the linters which are predefined, so it will help you catch even more problems. It will help you having the same strict format of the code, and then you can just focus on writing code in TypeScript, and you don't have to take care about anything else. So I think it's a pretty useful project. And as we have been talking about TypeScript, it's very important to remember that the TypeScript is a transcompiled language. So it's not only a superset of JavaScript, but it also compiles to JavaScript. So that allows you to take any JavaScript application and rewrite it into TypeScript, and still on the client side, on the server side with Node, it will still run properly. So for experimentation, if you don't even want to run Node.js and have a TypeScript compiler, you can go to the TypeScriptLang.org website, and you can go to the playground, and you can see on the left side how TypeScript version of some code looks like and how the TypeScript will compile it into JavaScript. You can already see, if you will look into some details in between of the lines, that those types are disappearing. And there is no information in the transcompiled JavaScript. So we are saying somewhere on the left side of the second line that the greeting is a string, but after we will compile it to JavaScript and then run it on the client side, for example, on the browser on Node.js, you will notice that this information as a string is not existing. So this is also one important thing to remember about TypeScript. TypeScript is doing static type analysis on the compilation phase. So it will not catch errors and it will not throw new errors whenever the type will be mismatched on production environment or on a running application during runtime. So it might seem surprising, for example, coming from PHP, but in the end it's a pretty easy thing to avoid this kind of problems, like avoid problems of, okay, on runtime having completely different types those that we annotated, those that we required in TypeScript. Because whenever you write your own code, the types in your code will be always the same, so they will never change. So the only thing which is changing the flow of the application is obviously the inputs to your application. So if you're writing in TypeScript, it's very, very important to properly sanitize and validate those variables. Because if you will check that from the client, there's a string coming and you expected a number, you should throw an error. And then later on in TypeScript, you are sure that this number that you have been requiring is actually a number. And you use a type of a number anywhere in your TypeScript code. So this is an important thing as well. So we've gone through it pretty quickly. There's just a tip of an iceberg of types and so on, but I really wanted to give you just a glance of what kind of features you have, and 2 or maybe 3 things that could be surprising whenever you're starting to work with TypeScript in general. So if you have any questions, this would be the time to shoot at me, and I can help you with anything. Please tell me.
2 questions. One question, which is your editor of choice? Because I'm using Visual Studio Code because, you know, it's something between cheap and not a normal notepad.
Yes,
and
yes.
How is it behave for you for very complex projects? I mean, dozens of components, etc.
Okay, so with bigger projects, I'm using IntelliJ because we are using the programming language. I'm using the programming language in my professional life as well, and there I'm developing not only in TypeScript, but I'm also doing Java. I'm doing PHP, Python. So it's really cool to have one IDE which handles everything pretty well. But it's good to remember that the Visual Studio Code is in the end was created by Microsoft, and it's having a really awesome support for TypeScript, because it's in the end is the same family of people who are working on it. So Visual Studio Code, we could say, that has a first-class support for TypeScript. In case of performance, I'm not really sure because I never had a big projects in Visual Studio Code. As I said, I am working in IntelliJ, but I wouldn't say it will be a big problem. The TypeScript has a very specific integration to IDEs. So TypeScript is exposing a TypeScript server, which you are running as a daemon, or maybe the IDE is running as a daemon. So this TypeScript server, the programming language server, is doing the interpretation on its own. So it doesn't matter. And then the server, then your IDE is communicating to the server, is asking, for example, can you tell me how I can refactor this? Can you tell me if this code is correct? And so on and so on. So more or less, almost no, very minimal functionality related to the TypeScript is in IDE itself. So in the end, it shouldn't really matter what kind of IDE you are using, because every heavy computation of TypeScript is happening on the server, which is running in the background and is being shared by all of those different IDEs. So I will be quite positive about the performance.
Okay, so second question, because besides PHP and JavaScript, I'm also a .NET developer. And one time I heard from one of the MVP, JavaScript is not a C-like language. It's more like Lisp-like language. Are there any movements to create something like MCL in case of C#, where TypeScript will be compiled and this intermediate language will be run directly on browser without any JavaScript? Because JavaScript is a kind of demon of the past.
Yes, it really is. I mean, I was also having lately a conversation with a Java developer, and when I was telling him about TypeScript, how does it work, that he's transcompiling to JavaScript, we got to the conclusion that, for example, Java is also transcompiling. It's compiling to the bytecode, right? So it's not that it's pretty unusual that you're compiling a language into intermediate representation and then you're running it somewhere. If there are some plans, I know that lately, like few weeks, or for sure this year, the creator of Node.js have introduced on some conference a new version of like Node.js-like environment, which is using TypeScript as a primary language. So I don't know if there are really any official big plans, or from Microsoft to have something running on Chakra, or maybe from this person that created Node.js. Not really sure. But in the end, I wouldn't be really worried about it, about this intermediate representation. Okay, so if you want to discuss my experience with TypeScript or have any other questions, you can catch me and we can discuss over lunch or a coffee or anything. I will tell you some more details about it. So it was great to speak to you, and thank you very much.